All right, we want to prove that an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So essentially, we want to prove that arc FJH is a semicircle of circle O if and only if angle G is a right angle. So since this is an if and only if statement, we have to prove it using the if and only if format, right? So we'll go ahead and do the first. P implies Q. So we're going to assume arc FJH is a semicircle of circle O, right? So since arc FJH is a semicircle, this implies that the measure of arc FJH, right, is equal to 180. Now, by the inscribed angle theorem, we know that the measure of angle G, since angle G is an inscribed angle, is equal to half the measure of its corresponding arc, which in this case is arc FJH. So half the measure of arc FJH, which we just showcased was 180, so it's half of 180, which is equal to 90. So this implies that the measure of angle G is equal to 90, which of course implies that angle G is a right angle. All right, so now we're going to go the other way. We're going to do Q implies P. All right, so we're going to assume, let me do a better job on that assume. Assume that angle G is a right angle. So of course, this implies that the measure of angle G is equal to 90. Now, by the inscribed angle theorem, we know that the measure of angle G is equal to half of its corresponding arc, which is FJH. So the measure of angle G is equal to half its corresponding arc, FJH. Well, for Q implies P, we know that the measure of angle G is 90, so this implies that 90 is equal to 1/2 the measure of arc FJH. So if we were to multiply both sides by 2, we'd get 180 is equal to the measure of arc FJH. And if an arc is equal to 180, right, that means it must be the semicircle of circle O. So this implies that arc FJH must be a semicircle of circle O. And that is our proof.